Alright, so going into Chapter 7 on the online textbook, we're talking about files. So far, we've learned how to write programs and communicate our intentions to the CPU using conditional execution, functions, and iterations. We've learned how to create and use data structures in the main memory. The CPU and memory are where our software works and runs. It's where all the thinking happens. However, once the power is turned off, we lose all of our data. Phones kind of are nebulous in this regard because they have flash, memory in them. But the flash memory works as a hard drive. So what you want is your data to be persistent. You wouldn't want to, take a census of the United States population and then have to re-enter it every time you want to do a calculation. You want to save all the data to files, or databases or whatever. So our programs have been transient, fun exercises. Well, fun is optimistic, but to learn Python. So generally what we need to do is to find a way to save our data. Save our data to disk. Now the big thing is cloud. Save your data to the cloud. What does that mean? You're saving it to a disk located on somebody else's computer. That's all it is. So in this chapter we start to work with secondary memory or files. Am I going to ever call it secondary memory again? Nah. Secondary memory is not erased when the power is turned off. Might be a USB flash drive or a hard disk. We will primarily focus on reading and writing text files, such as those you create in a text editor. Later on, we'll see how to work with database files, which are binary files, specifically designed to be read and written through database software. Reading and writing text files is pretty easy. I know we brushed upon it in our 1113 class. Not sure if all the other 1113 classes hit it. So what you want to do is you want the ability to open a file and to read from it. And the way that it gets read, traditionally, if it's a text file, it just starts from the top and goes to the bottom, just like you were typing data in to the Python prompt. So, our code that says enter a series of numbers. Okay, you could read those series of numbers from a disk. Now, we don't have to write the code that does all of the background stuff because fortunately Python and the operating system gives us all that information, all the functions necessary to do that. Opening the file communicates with your operating system, which knows where the data for each file is stored. If you think about it, it'd be really hard if you had to do it all yourself. If you had to query a disk drive controller and specify a sector, and move the head over there and read it. It's really nice that, everything is built on layers, and all we need to do is call an open command, and presto, we get it. Well, let's play with that. We're going to need two files. We're going to need some kind of data file, and we're going to need a program file, and we need them to be in the same directory. So I'm going to create two things with idle. One is I'm going to do a file new, and it's just going to be a normal Python file. Let's be really clever and call it October 24. Stored in your favorite homework directory, scripting directory, whatever. We're going to create another file and put it in the same directory, but it's going to be a .txt file. So after you get that first one made, and here I'll even put a comment that this is our script scripting file. This is, October24.py. Now we're going to create another one. So I'm going to go to File New, File Save As, but instead of a Python file where you see Save As type, make it a text file. And stick it in the same directory as your scripting directory. I can't think of a really clever name, so I'm just going to call it data.txt. Let's type some stuff into it. Hello, this is my text file, and it is incredibly awesome. Good enough. And then save it and minimize that. Now the textbook, the online textbook shows us just doing it from the command prompt. Yeah, we can do that, but then we're not going to do much with the command prompt after that. So I'll show you this. You don't have to type it. I don't care. I'm going to do f is equal to open and then give my file name, data.txt. And what do you know? No such directory or file. Okay, forget it. I'm not going to do it from the command prompt. I'm going to go back to my program file. So, and that's because I didn't start in the same directory. So I'm going to go back to my py script. F, they did fh for file handle. I guess I could even use the word file. File is equal to open data.txt. Now it would be cooler if this was specified in a variable. Why? So that maybe the user needs to type in the file name. So I'm going to cut that out. Hey, cut that out. And then make that file name. And I'm going to say file name is equal to data.txt. And then they suggest just printing file, printing out the file handle. It's called a handle when you open a file. Handle is just a reference to a resource that's located on your computer. You can have file handles. Back in the old days of Windows programming, you needed Windows handles so that when you created a new window, you could move it around and stuff like that. A lot of that stuff is encapsulated, but the term file handle is still used. It's like a handle. You grab the file by its handle so you can do stuff with it. Let's run it. Let's make sure that we don't get an error from not being able to open the file. All right, if I look at it, we get a lot of information here when I printed it out. It gives us the name of the file. It gives us the mode. Guess what R means? Reading. Yeah. Encoding is equal to CP1252. Let's Google that up. The CP1252 encoding and character set, otherwise known as Windows 1252, is a superset of ISO. Okay, it's just how data is stored on a Windows computer. That's very similar to how it's stored in a Unix. The real difference between Macs and Windows and Linux is whether they end each line with a character turn line feed or just a /n. I think that means a line feed. So if you get a program and it's only and the lines are only terminated with line feeds, and you open it with certain editors, then all you'll see is all your data on one single line. Notepad is infamous for that because it's expecting character turn line feeds on the end of every file. And so Mac and Unix are only expecting the line feeds. They'll accept the character turns, but it's not expecting them. The newest versions of most Windows apps will save only with line feeds, but there are a lot of other things that'll still write them with character turn line feeds. Doesn't really matter to us unless you try to read something in and it looks like the data is all in the same line. I don't think we're going to hit that circumstance. But if you ever use Notepad or something to edit a TXT file, or you use any editor, and every line of your document is just all on one incredibly long line, that's what happened. The character turns are messed up. So open it in a different text editor, copy it and paste it into the one that you're trying to use, if that makes sense. All right. Going back to our program, let's do something a little bit more useful than just opening it and printing out its file handle. So, open, close, read, write. These are things that your program can do to a file. If the file does not exist, it will fail. It will generate an exception. So you might want to put your code in a try except. For example, my file name is data, or date, what if I made it dat1 and I run it? It's going to blow up with a red error. Not surprising. That file doesn't exist. So we could put that in a try except block. Make sure that we handle that case. I'm just going to undo that for now. Let's get the base concepts down before we go ahead and make it bulletproof like that. So his example here is if you open an email message, the raw file for it looks something like this. This syntax dates back like to the 70s or something like that in it. So when you open, when you see your email, on your phone or something like that, and you see a very, what it's doing is it's opening, and it's just pulling out bits of information, like the subject, things like that. And we're going to skip all that. We don't care about the details of that, but we might care about how to read it. So, for every line in the file handle, do something. Here we're using our for something in syntax, just like we were doing for x in range. This is kind of a weird syntax. It isn't quite how you would do it in Java or C++ or something like that. But it works here. This is expecting that the file handle knows how many lines of it in advance, or at least can feed it to you with this syntax. So let's go ahead and do something like that. Let's go back to our program and do for every line in our file, let's just print that line out. Let's see if that works. Alright, it says, hello, this is my text file, and it is incredibly awesome. So guess what? Why are we seeing these blank lines here? It is because it is counting the \n, the character turns that were encoded when we edited in idle, as part of the data. So if we could look at this with a digital microscope and see the whole thing, this string consists of THIS space IS \n. So when we print it out, it's printing it, it's going to the next line, and then what does print do? It automatically goes to the next line again. If we wanted to fix it, and this isn't a permanent solution, this isn't really how we wanted to fix it, but one change we could do, probably the shortest change, would be to do this. Go back to your program, and do you remember that end parameter? Print line, comma, END is equal to empty quotes. That would stop the blank lines. Hello, this is my text file, and it is incredibly awesome. But I would rather remove those invisible /n's rather than cheat with that print statement like that. I don't want those /n's at all. Those /n's are considered white space. Do you remember how to remove white space from the beginning or the end of a string? We had a command that would do that, a function.
String.strip.
I think it's strip. I never can remember if it's strip or trim. But let's do that. For every line in the file, line equals line.strip, and then take that comma end equals end quote stuff out. And you know what? Maybe we only want to rstrip it. Maybe we only want to get rid of the data at the end, but we'd want to keep the white spaces. But let's give this a shot first. All right, that worked. That worked. But I'm going to change it to rstrip. Why? Because I only want to nuke the stuff at the end of the string rather than the end. Why? What if I had tabs in my text?
Just return, not write.
Pardon me?
R's for return, right?
R's for right, and L strip would be left. But yeah. So if I go back to my data.txt, I'm going to put a tab in it so that when I print it out, one of the lines should be tabbed. And if I used strip, I could run it both ways. We wouldn't see the tab. Using rstrip, I do see it. But if I take the R out and just leave it strip, you know what? That's a good point, though. Don't we have that replace function where we can replace all of the... I'm just playing at this point. I'm going to comment this out, and I'm going to say line is equal to line.replace every character turn with a, I don't know, an exclamation mark just for fun. I want to see if this works. All right. So you saw what it did. It removed the backslashes and replaced them with exclamation marks. So if I didn't want to see those exclamation marks, I could just replace them all with an empty string like that. Hadn't thought of that before. Both are perfectly good ways. I kind of like strip because what if they had extra spaces as well as carriage returns at the end of the data? They might not, but you know, strip makes it look as clean as possible, or R strip. So I'm going to comment that out and go back to using R strip. But I'm going to put a comment here as to what that did. This would replace all new line characters. Okay, this is a long comment. Would replace, remove all new line characters. Alrighty. So once you have a file, you can do stuff with it, you know. We could make a file that was a series of numbers to add up. What if we didn't want to print lines that began with a hashtag, just like comments? Let's do that. Oh, do you remember that test question that said, you know, how can you check to see if the first character is an H or something like that? There's like 3 or 4 different ways of doing that. I mean, let's just play with one of them. The easiest conceptually is probably this. If line 0 is not equal to a hash symbol, then print it out. That's one way to do it. But I could have also used begins with, or I could have used find to locate the first hashtag in it, and if the value of it was equal to -1. But this is good enough. Okay, so if we have any lines that begin with a hashtag here, then they would be left out. I'm going to go back and change my text file so that it has some comments. This file is really cool, isn't it? And I'm going to add one at the bottom. End of file. You know, whatever. You don't have to use the same comments in the same text that I do. But when I run it, since I'm telling it to skip every line, well, I'm not telling it to skip every line, but I'm checking, and if it begins with a hashtag, I'm not going to do anything. But if it doesn't begin with a hash, then I'm going to print that line out. All right, so it left out the lines that begin with a hash. Alrighty. And what are we going to do next? Let's go ahead and write something that will add up all the numbers that are in the file. If we do that, we probably want to delete all of this stuff. That's my guess. Or we could create a new file. Let's do that. Let's create a new file. So File, New File, Save As, Scores. Put it in the same directory as all your good programs, but make sure you do a Save As text file. If you don't click that, it's going to put the extension .py on it anyways, even though you type scores.txt, you're going to wind up most likely with scores.txt.py. So when you do a save as, make sure it's a text file. Alright, let's add some numbers in, whatever they are. I guess we could toss in some floats. Now, as soon as you're done reading from your file, you should close the file. Why is that? Because sometimes if you have a file open, especially if you're writing to it, the file will be locked by the operating system. Why? You don't want some other user to come along and delete the file while you are writing to it, right? And if the file is locked, you know, your backup program may not be able to copy it or open it or do anything with it. So in general, as soon as you're done reading your file, you need to close it. And our program didn't do that. So before our next line, our next code, which is going to open scores.txt, we're going to close the file. So unindented, all the way back here, close file. It's just good housekeeping. Yeah, the file gets closed as soon as the script is done, but what if the script, you know, was in a loop and, you know, was going to run for an hour before it was done? And then that file was locked, you know, held open by the operating system for an hour. That wouldn't be cool. All right, now we need to do it again. Let's change our file name. File name is equal to scores.txt. And let's do the same thing we did. You know what, we don't really need that print file statement up there. I'm going to comment that out. Then I'm going to come back down here and do the same kind of stuff we were doing before. File equals open, parentheses, scores.txt. Now what? Let's run through it and just get out our numbers, just like we did on the other one. For line in file, colon, let's strip it. We're going to strip off spaces from the beginning and the end because it's just pure data, right? We don't need tabs in it. Line is equal to line.strip. Let's print it out. And that's enough. Why don't we print a done and close that file? And I actually hope this works. A common problem students have, and I've done it too, is I'll type in all this data but I forget to save it. Right? You know, I made a new file, I type in some data, but I forget to save it, and then I change it, and I forget to save it, and so then I get frustrated wondering why my changes aren't showing up when I actually run the program. So just save your data file every time you change it. Alrighty, close is not defined, so I goofed on that. Why don't we go back to our documentation and see how we close a file. Oh, excuse me. It's dot close. Alrighty. We're going to go back and modify our close statements. It's not close file. It is file.close. Same thing down here. We had two file closings, right? The bottom one also needs to be file.close.
You don't have to define it in parentheses.
You do have to do file.close, but you don't put anything in the parentheses because it knows which file we're closing. Right? It's not like file.close is a command. It's closing the file. So if we change the name of our file to Fred, we'd do Fred.close. Maybe I should have chosen another file name other than file. We'll do that on the next one. Or excuse me, another variable name. Alright, so it read in all my numbers. Let's modify our code so that it adds those numbers together. And then calculates the average. And same boring stuff. What do we need up here at the top in order for that to work? Before we start reading our data, we need an accumulator variable, right? So let's make a variable called total. Now we can't print this line because this line is text. It's not a number. Excuse me. Of course we can print it. We can't add that line to the total because it's a string. It's not a number. So what do we need to do in order to add it?
Plus equal line.
Yeah, if I do total plus equals line, it's going to tell me it's not a number.
Oh.
So we have to convert it. We have to convert it to a float. So let's do something like this. Value is equal to the float version of the line, and then total plus equals value. And it would also be cool to keep track of the number of lines, which in that case we're going to do exactly what you said, which is we're going to add 1 to it. So along with our total, let's declare another variable up here underneath total is equal to 0. Count is equal to 0. But every time we add value to the total, we also want to add 1 to our count. Count plus equals 1. That way we can calculate the average and stuff like that at the bottom. Which we may as well do. So above our print statement, I guess we could have moved that print statement below file.close, but whatever. Average is equal to total divided by count. Hopefully there is data in it, or else if we're dividing by 0, it's going to blow up. And then let's print the total equals, comma, the total, and print average equals, comma, the average. I really would like that done statement to be underneath the close. So I could just cut that done statement and I put it beneath the close. Okay, so there's our code. File is equal to open scores.txt. We declare 2 variables, total equals 0, count is equal to 0. I shouldn't call it declaring in this language. We initialize 2 variables. For line in file, colon, we strip the line. We print it out, but that's not strictly necessary, is it? We could just read it and print the sum, the total, and the average without even bothering to do that. And then the value is equal to the float version of that data. The total plus equals the value. The count plus equals 1. Then we need the average. So outside of the loop, untabbed, we have average is equal to total slash count. Then we print our total and we print our average, and maybe it's going to work. Let's find out. All right. I expect that that's accurate. I'm not going to go back in and add them myself. Now let's maybe do something even cooler than adding numbers. Let's create a... You know what I'd like to do, though, is to do the same trick of where if it begins with a hash symbol, we ignore it. What could we do to this loop right here to make it so that if the data begins with a hash sign, we don't do anything with it? I would need to modify. I could add an if statement of some kind. Where would I add that if statement? There's more than one answer, but the logic I want is if the first character of the line is a hash, don't do anything. So where am I gonna add my if statement? Yeah, we could do it before the print statement or after the print statement. I think I'm gonna just do it before. So if the line at position 0, if line subscript 0, line index 0, slice of line at 0 is not equal to a hashtag, is not equal to # hash. Now we need to tab the rest of this stuff over like that. I generally like doing that so that I can put comments in my text file, you know, whatever kind of data it is. If I need to explain a certain value in it, I can put that comment in the text file so if anybody ever read it, they could understand what it was. I'm going to test that. Excuse me. Go back to data. No, I'm done with data.txt. I'm going to close that one. But I'm going to switch back to scores.txt and add some hashes just for fun. I'm going to add 1,000,000 as the last comment, you know, something like that, just to prove that, you know, if this wasn't being ignored, it would blow up when we called float on it. Let's see if that's the case. All right. So obviously it skipped that line, which was my desired behavior. All right, we're going to do one more text file. I mean, we may do many more, but here comes another one. Do a file new, do a save as, and call it payroll.txt. And then I better wander around and make sure everybody's doing okay. So as soon as you create this file, and I get you started on typing, and I'm going to wander around and make sure that everybody's doing okay. So payroll.txt, and change it to a text file. And save. And here's the format. Type in a name, followed by a comma, followed by a number of hours worked, followed by a comma, followed by their salary per hour. And we're going to make this one ignore hashtags too. So the data format is name, comma, hours worked, comma, wage, right? Now just add, like 10 or 20 lines, 10 or 20 payroll. So it turns out our program is going to crash if we have any blank lines in the data. I didn't have any blank lines in my data, but ignore payroll for a moment, go back to scores and insert a blank line. How do we want a blank line to be treated? Do we want to be treated as a 0? Nah, I'm going to just do the same thing that we do with the hashes and completely ignore it. But first I'm going to prove that it crashes. So now that I have a blank line, kablooey. It says if line index 0, string index out of range. Why are we getting that? Because it's an empty string. There's not even a position 0 for us to check. So we need to modify our if statement a little bit. Along with if line subscript 0 not equal hashtag, we're going to modify that if statement. And this is in the scores.txt program, but we really should have made the change to the other one too. So if length of the line, so if len parentheses line in parentheses is greater than 0 and the line subscript 0. So we got to rule out this case. This case is that it's an empty string. There's no data in it at all. And just for thoroughness sake, I'm going to take that new stuff and I'm going to put it into my other code up here as well. So that one also says that the length of line is greater than 0 and the line at position 0 is not equal to hash. All right, that should fix that. All right, what are we going to do next? We're going to write that payroll program that uses that payroll file we were working on. Now, I don't have any payroll data yet. Oh, wait, have I messed this up? Are we all good or are we broken? I guess I better check. All right, this time I want to choose a different name other than file. So I'm going to call it FIN for file input. Or I could just call it IN, huh? No, IN is a keyword. That would be bad. So FIN is open to, well, let's redeclare our file name variable. File name is equal to payroll.txt. And an FIN, file input, is equal to open file name. Now we need our kind of for statement again. For every line, for every string, I'm messing with our variable names just a little bit so that you don't think that those are actually part of the syntax. For every string in the file, for S in FIN, let's strip it as always. S is equal to S dot strip. But now we want to split it. Why do we want to split it? Oh, I never did finish creating my file. I'm going to go back to payroll.txt and put more. Susan Rand, comma, she works 30 hours a week, $12 an hour. You know, Sally White works 20 hours a week at $20 an hour. And I don't have to be typing in that .00, do I? So, and then Jimmy John, working 50 hours a week, $10 an hour. All right, I have 4 pieces of data. That's enough. Whatever y'all put in is fine. Doesn't have to be my same data. So I save it. Okay, I'm going back here to our payroll.txt portion of our code now. I strip it. I need to make sure that it's not empty and that it doesn't have a hashtag before I do anything else. So if, same kind of thing. If the length of the string is greater than 0 and S subscript 0, I'm going to use S dot begins with, just to confuse us, to be different. And S dot begins with I'm going to erase that. Although I'm going to use not this time. No, I'm going to just stick straight with what we know. Don't get fancy. So, and string S square braces 0 is not equal to a hash £. Now we're good to go. We want to split that string up. I'm going to just call this data. Can't think of a better name. So data is going to equal s.split, like that. And then let's print it out. Let's just see what data looks like before we do anything else. And then we need to close fin outside of our file. So fin.close. That's the last thing we do. I goofed, pardon me. Yeah, you're right. Yeah, that would be an error. fin.close. Alrighty. So let me pull this over here. But when it ran, look what it did. It created a list. This list says Joe, Bob, as a separate item, 40. And 10. I really don't want it to be split up by spaces. I'd like for it to be split up only by commas. And why do I say that? Because I want the name to be just one thing, right? You know, because if Prince is here, or Cher is here, or Bono is here, you know, then our number of items in the list would be different if somebody had 2 names or 3 names or 4 names. You know, John F. Kennedy Jr., 4 names. I guess he's not collecting a big paycheck anymore. But anyways, so we need to change the split command so that it only splits based on commas. So I'm going to change it s.split. And I'm going to put quote, comma, quote in there. Hope that does it. Let's find out. It did. That fixed it. So that the first entry in the list is Joe Bob. The second entry in the list is the number of hours worked. And the third entry of the list. Okay. So we're getting into list processing again, right? Except our list this time consists of disparate data values. Right? It's got a string followed by 2 numbers rather than just being a series of numbers. But that's okay. Let's get our data back out of it. Name is equal to data element 0. Hours is equal to data element 1. And the wage is equal to data element 2. And I think I'm going to comment out that print data. thinking that our output's going to be messy. So how do we calculate the salary? I'm not going to do time and a half, right? So I'm just going to write pay is equal to wage times hours. And forget time and a half. We're a harsh business here. Nobody gets overtime. I guess if we were really harsh, then we wouldn't pay them for any of their work over 40 hours anyways. But okay. So now we've calculated their pay. But we've got a problem. I've already realized what the problem is. I could let it run. But what's going to happen when we multiply wage times hours? Yeah, they're both strings, so it's going to blow up. So I need to convert hours and wage to floats.
I ran it before we get paid, and it goes back and gives me list indexes out of range for 2.
Okay. Let me run it as well and see what happens. So I'm going to try to do float data 1 like that, and then float data 2 like that, and then I'm going to run it. I want to print though. I'm just going to print the name and then the pay, just to make sure I'm getting something happening. And I'm going to see if I got the same error that you did. No, mine worked. So let me come back and look at yours. While you're waiting, okay, so we ran into a problem to where if we misformatted our data, like one of our commas was accidentally a point, we didn't have 3 data items in our list, we only had 2. Pardon me?
Mine's blowing up.
Okay, cool. So to fix that, we could do one more thing, which is after we split it up, we could do this. If the length of our data is equal to 3, then do all this stuff, right? We're just doing a little bit more data validation.
X or something like that, or was it?
Yeah, you could have called it anything, but it would still have to be ASCII text for our programs here to work. All right, I think that's about enough. We could put some else statements on here to print why we're ignoring this stuff. This looks like a particularly alarming case to me. If the length of the data is not equal to 3, it meant that it was malformed, and we might care about that. Also, our program is kind of inadequate because we're not doing try-catches. Let's fix this last one so that it does try-catch just before we go. It's going to involve a mass tabbing, huh? So, before the fin equals open, do try colon, and then tab that fin equals open. And then on the next line after fin equals open, do except colon. And then tab everything underneath that. All the way, even including the fin.close. So after the except statement, highlight all that stuff and just hit the tab key. But, oh, I goofed that. I totally goofed that. That's not going to do it. Take that except statement out and move it to after fin.close. You see what my mistake was? I was putting all of this code inside the error handling code. But no, this is what we want it to do if it's good. So now it says try colon, and then everything underneath that is indented. And then down here, except colon, unindent that, and let's print out an error message. Print could not open, and let's print out our file name. And just to test that, I'm going to change my file name to something that doesn't exist, like payroll2.txt. All right, could not open payroll.2.txt. That's a little bit better. Alrighty, our homework based on this is going to be this kind of idea. I'll type it up a little bit better, but you're going to have series of numbers like this. There may be a different number of values per line. What I want you to do is open the file, read in the line, convert it to a list, add all the numbers in the list, print the total and the average, and then I'm just going to add as a parentheses. Okay. And then for each line in the file, convert it to a list, add up all the numbers in the list, print the total and the average of those numbers. So your input's just going to be a text file full of numbers. Could be a different number of length, of numbers on every line. But do the same thing. Make sure it ignores lines that begin with a hash or that have a length of 0. Let's make it even fancier. Ask the user for a file name. Open that file. And then after we've printed the total and the average of all those numbers inside the for loop, once the for loop is done, we need to close the file. All right, I think that's enough. Fairly similar to our assignment, right? But just a little bit different. I didn't want to make this exact same assignment. All right. Let's stop our, pardon me?
Is it those 3 you have open on there? Look like you open up some new ones for next week.
Yeah, we've got a couple of new assignments that have been opened. Let's go take a peek at those real fast. Let me make the Dropbox first.
Now, when submitting those, we have to submit the doc.
Yes, please give me the text file as well. Yeah. All right, LMNOP. I mean, I can make my own. That'd be a good idea. But I'd like to see your text file as well, because if it doesn't work on mine, I'd be curious as to why. Still think it's September. And of course I forgot to put it in the right folder. All right, let's look at our new homework assignments. Chapter 7 has a couple of file I/O tutorials. Kind of need to eyeball them to make sure that they don't exactly match the homework assignment I'm just giving y'all. CH7A is directly from the textbook, I believe. So let's take a look at CH7B. All right. This one's kind of similar. Enter this script largest.py, but then modify to read from a file rather than a keyboard. So you're going to have some changes to make to it. All right. So this one's actually not too bad. You just read in a series of values, and then you find the largest of that series of values. And you know what? If you want to completely ignore the sample code and write your own for it, I think I'll rewrite the assignment to that effect. Then yeah, you can do that. Alrighty. Any questions? Need the code again? Alright, let me stop the recording and then I'll do that.